Hello, everybody, and welcome back to another Geek Out session with Real Science with Chris Neal. Thank you guys so much for coming. Hopefully you'll enjoy this one. This one is based off of a poorly understood mechanism inside the cells of all of our bodies, the AMPK system. So I really like this one, so hopefully you guys will enjoy. If you do like this kind of stuff, please make sure you hit the like button, subscribe, hit the bell, so you know when my next video is popping. So if you guys have any questions, then please hit me up in the comments below. Or if you'd like to check us out in the clinic, you can hit us up at www.team360health.com. So let's dive in. In order to go through the AMPK system, we really needed to roll it back and take a close look at what this system is actually referring to. Do you guys remember ATP from back in the day, back in middle school, high school biology, where we learned about the Krebs cycle, the citric acid cycle, the electron transport chain, all of that fun stuff? Go back in the attic, it's up there. ATP is stored energy. That's how our cells, our cells store energy in the form of a bond that connects the phosphate group to the adenosine molecule. So when that happens, it stores that energy in the form of a chemical bond. Once that bond is broken or released, the energy is released and we can use that energy, the cell can use that energy to do whatever it needs to do. So that's really what we're talking about here. Whenever we break one of those phosphate bonds, we go from ATP to ADP, adenosine diphosphate. We break another bond, we've got AMP. Okay, now in the AMP form, that's it. You can't do anything else beyond that. Okay, we've already burned off all our bonds. So when your AMP is low, there's a ratio that the cell is always keeping an eye on. Most of this is occurring inside the mitochondria, the energy generator for the cell. So when this ratio of AMP to ATP is low, that means the cell is in what's called a low energy state. So one thing that we were learning about how not only the human body works, but how the cells work is that everything is controlled through signaling. Communication is key. Communication is king, really, when it comes to everything working the way it should. There's a lot of factors and a lot of different aspects that need to be communicated through to make everything work in concert, which is what we call homeostasis. So basically, when your cell is in a low energy state, everybody needs to get on the same page in order to rebuild the ATP again, okay? And resupply our ATP. In order to do that, we need to switch some things around. And that's what the AMPK process stands for. The K part of AMPK stands for kinase. So it's related to an enzyme. So an enzyme is like a helper that helps out with a chemical reaction. Very, very key. A lot of times the process cannot go without that enzyme in there. So when you're in a low energy state, and that can come from exercise, from stress, or from fasting, a low energy state stimulates a refreshing of your ATP again. And then that stimulates a bunch of things happening. So now what we can do, once we understand the system, we can figure out how to go in and manipulate the system and try and tweak things in a way that's going to be best suited for our goals. And that's really what this is all about. So we know that the low energy state is initiated by exercise, the cell itself burning off a lot of its ATP. It can come from stress, and that's also, that also stimulates the cell to burn a lot of energy. Or fasting, if you're just running out of nutrients. The problem with fasting, yes, I know a lot of people out there, I'm going to get a lot of flack for this. A lot of people really enjoy fasting, and fasting works great for them. That's fine. But the science of it is that fasting is a form of stress. So this does not happen in just a microcosm. There's so many other variables and factors that go all together. I'm not a huge fan of consistent fasting, I'll say that. But fasting is one of the things that does stimulate the AMPK process to begin communicating with other parts of the cell. Okay? So what is globally, big picture, what is this? What are we actually doing here? When the energy levels are low, the first thing the AMPK is going to do is going to travel to the cell wall, and it's going to try and draw in as much glucose as it can. Okay, because we need some raw materials of energy, glucose, in order to create more ATP and get it going, right? So one of the things that it does is that it's going to increase your insulin sensitivity. So glucose is actually carried through the body with what I call a delivery service, or your insulin, right? So insulin is carrying glucose to the cell. Glucose can't just walk itself into the cell all on its own. There's special doors called GLUTs, or GLUT, glucose transporter mechanisms. They sit there. They're basically like, it's basically like a drawbridge for the castle, a drawbridge for the cell, the plasma membrane. Okay, so AMPK is going to go up to these drawbridge operators and say, dude, if you see glucose coming through being carried by insulin, let them in. We got to bring in as much of that. And that's called insulin sensitivity. Insulin resistance is the opposite. That's what we don't want. That's diabetes. That's inefficiency. So one of the first things that AMPK is going to do, it's going to go to these drawbridge operators and really bring in as much glucose. So any glucose that's outside of the cell, that's drawn into the cell, that's a good thing, because that glucose, once it's inside the cell and it's getting worked on and metabolized, it can no longer be converted into fat, not in this state. So that's what we want. We want to burn that glucose off as quickly as possible, insulin sensitivity. So the next thing that it's going to do, it's going to signal the body in various ways to burn fat. There's a ton of AMPK activity inside the liver. The liver's like Grand Central Station for what your body wants to do with its metabolism, especially when it comes to fat. So you're going to be burning more fat when AMPK is activated. Fat synthesis. Are you going to be building fat and creating fat? No, that's the opposite of burning fat. So we want to shift everything into that philosophy, and that's really what that's all about. So increasing insulin sensitivity, burning fat, and decreasing fat synthesis is what it's all about. The next thing that AMPK does, which I think is really cool, is called autophagy. Autophagy. Autophagy is basically the cleanup crew. So it's a way of reassessing the cell to see if the cell is even doing anything. If your AMP to ATP ratio is really low for a significant amount of time, you got to ask yourself, it's like, what are we doing here? Is this cell even doing anything? Is the cell dead? I don't know, but somebody should be looking and checking it out. And that's basically what this is. So is somebody checking out the cell just to make sure that things are still working the way it should? Or should we just scrap the cell and build another one? That type of cleanup is really, really important. It's very critical, not only to clear your body from dead cells or senescent cells, but also to clear your body of potential cancerous cells too. So it's a really important aspect of AMPK getting activated that does that. The next thing that AMPK does is that it undergoes what's called mitochondrial synthesis. So your cells don't just have one mitochondria. Some cells have tons of mitochondria, depending on what the cells do. Like the muscle cells, for example, are constantly active, constantly working and moving. The more you exercise, the more mitochondria your cells have, because with this exercise, it's going to trigger AMPK activity. AMPK is going to stimulate the cell to build more mitochondria and build more efficient mitochondria. So really, really important, which all that's going to do is just fuel the whole system even more. And you got a snowball effect of all good stuff happening. So all of these things, even though catabolic in energy and fitness terms is typically a bad word, these are catabolic things that are actually beneficial. True fitness and true health and staying lean and building muscle, it's a combination of catabolism and anabolic character. So the two of them together. So these are all catabolic events. Now, the anabolic events are actually depressed when AMPK is activated. So protein synthesis is an anabolic event that's building up. So there's really not a lot of protein synthesis that's undergone or it's not activated and initiated by AMPK. Fatty acid synthesis, we talked about this earlier. The body's not going to be building and storing into fat as much because we need the opposite right now, right? So sterol synthesis, same thing with cholesterol. Your cholesterol numbers, cholesterol is going to go down if you can activate your AMPK system more often. Glycogen, like I said before, there's a lot of AMPK activity in the liver. The liver is a primary storage center for glucose in the form of glycogen? Do we need to be storing more stuff right now, or do we need to be utilizing it to form ATP? That's what we're trying to do here, the opposite of glycogen synthesis. So all of those things would be anabolic in nature, and we're actually doing more catabolic in nature type stuff right here. So that's basically the rundown as to what we're talking about here. Now let's go into the picture. So this is a picture of a cell. So I wanted to use this picture to talk about 3 different medications that are out right now that affect this system in a really cool way, in all different ways. But first we have to understand how the truck works, how the AMPK, the natural AMPK system communicates with everything. We got to get a good understanding, a good picture of that first, and then we'll know how the 3 medications do their job. So the first one we're going to talk about is called SLU PP332. I know I didn't come up with a name, but I did do a video on this a few months ago. So you can check that out, and we go into a very, very deep dive into how SLU PP332 works. But for this video, I just want to talk about some basics. It's what's called an exercise mimetic. It's in a category of medications that basically mimic the chemical response that your cells would be getting from exercise. It's mimicking that to try and trick your body or trick your cells into thinking that you're exercising even when you're not, from a metabolic standpoint. It's really cool stuff. So the way it works, and please understand, I know before I hear it from everybody, like the picture is a very generic and simplified imagery of what's happening inside the body. I did that on purpose to try and describe this in as easy a way to digest as possible, because it is incredibly complicated. But it doesn't have to be if we understand big picture. So that's really what I'm after here. So a lot of this stuff is not drawn to scale, or it might not be perfect, but it's in a way to enhance understanding for the biggest group of people, which is what I'm all about here. So your SLU PP332, that is a pill that you take. And as a disclaimer, let me also say that with any of these medications, you want to make sure that you talk to someone, to a medical practitioner that is trained not just in peptides or one thing or another, but they're trained in all health and all medicine, because everything is connected. They need to understand how your heart works. They need to understand how your metabolism works. They need to understand if you have any pre-existing conditions. Like, all of these things are very, very crucial. This is not something that you want to rely on someone that just did a quick Google search on this stuff. Like, they really need to understand these pathways very well before they recommend anything or really talking to you about how to use these things safely. So make sure you find a really good one, someone that really knows what they're talking about. If you need help, I know a guy. You can hit me up at team360health.com, and I'd be happy to work with you. So SLU PP332, that is a pill that you take. You can take it frequently throughout the day. Find a medical practitioner that understands this stuff first. The way it works is that it goes into the cell, and then it actually works its way into the nucleus. The nucleus is like the brain of the cell. It's the executive center. They control a lot of stuff inside the cell. And there's a section inside the brain, inside the nucleus, that I like to call mitochondrial management. Now, the mitochondria, that's the generator. That's the energy producer of the cell. And a lot of times there's a lot of them. There's many of them. So it's going to go in and activate the mitochondrial management of the cell, telling the entire cell from the top down, look, guys, we need more mitochondria. We need better mitochondria. We need to increase efficiency. We need to build energy, and we need to get this going, because there is energy, or there is exercise occurring right now. This is an exercise mimetic. So this is the exact same pathway that stimulates the mitochondrial management every time you exercise. We're just doing it more often, whether you're exercising or not. You can take one of these pills, and it stimulates basically the same thing. So it's pretty cool. It's pretty cool. That's going to send that signal from mitochondrial management to the mitochondria, and to build other mitochondria and actually get things going. This is actually stimulating genetic activity, genetic action in the genes to process some translation and get some stuff going. So it's pretty cool. Really neat. The next one we're going to talk about is a combo. This one is MOTS-c and CB4211. So this one I'm not going to go into. I can do a whole video on that, and I will. But these two are essentially the same. CB4211 is an analog of MOTS-c. MOTS-c is something that's natural, that comes from your mitochondria, and it's a way that your mitochondria can communicate with the rest of the cell to tell it what's going on and to actually stimulate things. So when the mitochondria, so these two medications, MOTS-c and CB4211, those are in a new category, a totally new category of drugs that's out now called MBTs, Mitochondrial-Based Therapies, okay, or therapeutics. So these medications are based on the idea that the mitochondria is super important, especially when it comes to obesity, fat loss, burning fat, building muscle, your metabolism. Like the mitochondria is the key source for that. So the medications that focus on the mitochondria are really, really powerful. So here we go. So the MOTS-c is a signal that comes from the mitochondria under times of stress and exercise and fasting, and it stimulates AMPK. It's the way the mitochondria talks back to the AMPK communication system to say, hey, can you help encourage more mitochondrial activity? Can you, because remember, there's multiple mitochondria. So if one mitochondria starts slowing down a little bit, it needs to have a way to talk to all the other mitochondria and the whole rest of the cell to communicate, hey, we got to pick up the slack somewhere. So that's a really cool way of sparking the entire AMPK system all throughout, okay? And CB4211 is just an analog of that. It just so happens to look very, 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 very similar, almost identical to MOTS-c, okay? And those two are both injectables that you would be taking, okay, or you could take. Get with your medical practitioner first. Okay, so that's what those are. So the third one we're going to talk about is something that's called ATX 304. ATX 304, this one is a pill you can take. It has two main factors. It is what's called a Pan-AMPK activator. So basically what that means is that it activates multiple angles towards the AMPK system. Okay, it's going to hit from different angles. One, it's going to go straight to AMPK and activate it, activate the truck and get them communicating. It's also going to activate the mitochondria itself, okay, and stimulate the mitochondria. In the same kind of way that AMPK would be stimulating the mitochondria, ATX 304 is going to do it by telling the mitochondria, okay, guys, you got to get more efficient. You got to crank things up. We need more energy. We need you to drive the system up this way and create more ATP and burn more glucose, okay? Burn more glucose so we can create more energy so we can metabolize stuff and get things going here, all right? That's the ATX 304. The second thing it's going to do, and this I think is really, really neat, it's called, its second action is called mitochondrial decoupling. So it is it decouples one of the actions of the mitochondria. One of the things that the mitochondria does is that it will, as it's converting or as it's trying to build ATP, you've heard of the electron transport chain, right? So it's drawing in all of this energy and it's going to focus this energy towards building a chemical bond, okay? And we call that chemical bond, converting from ATP or ADP to ATP. So it's drawing in all of this energy and then it decouples the assembly line. So it's no longer able to take that energy in and focus it into building a bond. So what's going to happen to that extra energy? Energy cannot be created or destroyed. We know that. So that energy is just dissipated as heat. So when that energy is just dissipated as heat, the temperature goes up a little bit. You feel a little bit warmer, okay? And just that small change of that energy being floated away, basically, or being burned off as heat, we're not building up ATP. We're staying as AMP, okay? Which is yet another signal to keep the AMPK active. So it's really cool in that you're basically melting off extra energy, extra calories, basically, for free. you know? So that's basically what's going on there. And you're stimulating you're not only that, but you're stimulating the whole snowball effect for things to continue on and over again. So ATX 304 is really, really powerful because not only does it boost the AMPK system and all of this stuff happening, but it also will decouple a lot of the energy formation here in the form of ATP, and it'll keep the process going. As long as that's decoupled, it's just going to fuel the process more and more and more. Okay. One thing in the picture that I didn't mention is that I might have mentioned it, but there's a transporter here called your glucose transport system, and that's where insulin comes in. I think we did talk about that. But yeah, this is my little picture here of our nucleus, our mitochondria, and then the 3 medications. Please make sure, like I said before, that you talk to someone, a good medical practitioner that understands these things before you just jump into just popping pills and popping medications that you don't know where or how they're really impacting your body. That's really, really important. We really dive into that in our clinic, team360health.com. I'd love to talk to you guys. If you have any questions or you'd like for me to dig in and do another Geek Out session, please feel free to hit me up in the comments below. Hit the like and subscribe. I'd be happy to chat with you. And who knows, maybe your topic will be the next one that I geek out on. All right, guys, thank you so much for your time, and hopefully you enjoyed it. And until next time, stay healthy.